The human brain is a marvel of complexity. It operates not in a linear hierarchical fashion but through an intricate web of recursive feedback loops. These loops are the essence of its processing power. Imagine a continuous flow of information constantly being refined and reshaped as it cycles through the neural network. Each loop builds upon the last, creating a symphony of activity that gives rise to our thoughts, emotions, and perceptions. This is not a random process. It is a highly organized system, governed by principles of feedback and recursion. These loops are not confined to a single area of the brain. They span across different regions, connecting distant areas in a dynamic interplay. The prefrontal cortex, responsible for higher-order thinking, is in constant communication with the amygdala, the seat of emotions. Information flows back and forth, shaping our decisions and reactions. The hippocampus, crucial for memory formation, adds another layer to this recursive process. It consolidates experiences into memories which then influence future cycles of thought and behavior. To understand this intricate dance of information, we turn to the torus. A torus is a donut-shaped object, a continuous surface with a hole in the center. This seemingly simple shape holds profound implications for understanding the brain. The toroidal model proposes that the brain's recursive feedback loops are organized in a toroidal fashion. Information flows through this torus, constantly being processed and refined. This is not merely a metaphor. The torus provides a framework for understanding how the brain integrates information from various sources. Consider the flow of cerebrospinal fluid in the brain. Cerebrospinal fluid circulates through the ventricles, bathing the brain in nutrients and removing waste. This flow exhibits vortex-like patterns, reminiscent of the toroidal shape. This is not a coincidence. The toroidal geometry allows for efficient circulation and distribution, ensuring the brain's optimal functioning. The toroidal model also sheds light on the elusive nature of consciousness. Consciousness is not located in a specific part of the brain. It is an emergent property of the recursive dynamics of the entire system. As information flows through the toroidal loops, it creates a feedback loop of self-awareness. The brain, in essence, observes its own activity, giving rise to the subjective experience of being. Brainwave patterns provide further evidence for this model. These oscillations, measurable through EEG, reflect the synchronized activity of billions of neurons. They exhibit fractal patterns, meaning they repeat at different scales. This fractal nature is crucial for information processing. It allows the brain to integrate information seamlessly, from the smallest synaptic event to the largest neural network. This integration is key to consciousness. It allows us to experience the world as a unified whole. The toroidal model has profound implications. It suggests that consciousness is not separate from the physical brain, but arises from its dynamic organization. The torus, a geometric shape, becomes a bridge between the material and immaterial aspects of the mind. It shows how complex patterns of activity can give rise to subjective experience. This model can revolutionize our approach to artificial intelligence. Current AI systems are largely linear, lacking the recursive, self-referential qualities of the human brain. By incorporating toroidal principles, we can create AI that is more flexible, adaptable, and perhaps even capable of a form of consciousness. The toroidal brain is not just a scientific model, it is a new way of seeing ourselves and our place in the universe. It reminds us that we are not isolated individuals but part of a vast, interconnected web of energy and information. It is a vision of the mind as a dynamic, ever-evolving entity, capable of limitless growth and transformation.